Okay, so we have two more examples that we're going to cover. We need to establish the identity, which means we focus on just the left-hand side. Do not touch the right-hand side. We'll use our fundamental trig identities. We'll use algebra, factoring, whatever we can to force the left side to look like the right side without actually touching the right-hand side. So, over here, I know that tangent can be rewritten as sine of theta over cosine of theta, plus cotangent can be written as cosine of theta over sine of theta, and then in our denominator, secant can be written as 1 over cosine of theta times cosecant is 1 over sine of theta. Okay, so let's deal with our numerator first. You're adding two fractions, which means you need to have a common denominator. And a common denominator for cosine and sine is to just smush them together and say cosine of theta, sine of theta. Okay. Now, on the top, you need to multiply sine of theta times sine of theta. So that becomes sine squared of theta, big fat plus sign. Now, your second numerator, you need to multiply that one by cosine of theta. This becomes cosine squared of theta. Okay, now, in our denominator, when you're multiplying two fractions, go straight across the top. 1 times 1 is 1, and cosine of theta times sine of theta is cosine of theta, sine of theta. Okay. Now, continuing on, up top, we know that sine squared of theta plus cosine squared of theta equals 1. So this becomes 1 over cosine of theta times sine of theta, big fraction bar, 1 over cosine of theta, sine of theta. And then when you have two fractions, keep the first one the same. So 1 over cosine of theta, sine of theta. Take the reciprocal of the second one, cosine of theta, sine of theta, over 1. And then when you multiply those, look what happens. It all cancels out, leaving you with 1, which is what we wanted it to become. So we know we did it right. Okay, last example. Taking a look at sine of theta over 1 plus cosine of theta plus 1 plus cosine of theta over sine of theta, we want to prove that it equals 2 cosecant of theta. Now we're starting with two fractions, and we have to force it to look like one answer. All right, well then you have to add the two fractions together. And to do that, you need a common denominator. So we'll just smush those two denominators together. So this will look like sine of theta times 1 plus cosine of theta. My first numerator, I need to multiply by sine of theta. So this will become sine squared of theta, big fat plus sign. And then I need to take my 1 plus cosine of theta times 1 plus cosine of theta. So this is going to look like 1 plus cosine of theta squared. Now on the top, that becomes sine squared of theta plus, when you FOIL that out, that would be 1 plus 2 cosine of theta plus cosine squared of theta. Now let's keep going with the numerator for a little bit. Nothing says that you have to leave it written in this order. Addition can be rearranged however you like. So let's look at this as being sine squared of theta plus cosine squared of theta plus 1 plus 2 cosine of theta. Well, we know that sine squared of theta plus cosine squared of theta is 1. So it becomes 1 plus 2 cosine of theta. Adding that together, that's 2 plus 2 cosine of theta. Alright, now we still have this all over our denominator, which was sine of theta times the quantity 1 plus cosine of theta. Now if you look at the top, you have two terms here. And what can you take out of both of those terms? Well, you can take a 2 out. When we do that, that leaves us on the inside with 1 plus cosine of theta over sine of theta times 1 plus cosine of theta, which is really nice because that 1 plus cosine of theta cancels out. So now we're at 2 over sine of theta, which we know is the same thing as 2 times 1 over sine of theta. And 1 over sine of theta is cosecant of theta, which is what we wanted it to equal. Done. Huh? All right, so your assignment for tonight is going to be on page 498. It's going to be numbers 20 through 32, every other even. So you're not doing a whole lot of them, but you have to show all of your steps, Tanner, all of them. And you just take the left-hand side, use algebra, use your fundamental trig identities, force it to look like the right-hand side, but never actually touch the right-hand side. Good luck.